Hello everyone, welcome to the design of buck converter. I'm Ganesh presenting the design of buck converter. In this video, we are going to see how to design the buck converter, component selection, circuit diagram, and rating of the switches. The problem statement for the buck converter design is design a buck converter with following specification. Input voltage is 200 volt. The output voltage varies from 50 volt to 150 volt. Load resistance is 20 ohm. The ripple in the inductor current is 20%. The ripple in the output voltage is 5%. Switching frequency is 50 kilohertz. So with this specification, we want to design a buck converter. So let us see the circuit diagram of the buck converter. For a buck converter, we have input source voltage, which is given 200 volt in this case. We have a load. In this case, the load is given as a 20 ohm. The voltage variation across the load is 50 volt to 150 volt. It must be controlled, the output voltage must be controlled to 50 volt to 150 volt, and that is a step down voltage from 200. So it is also called as a step down chopper or buck converter. So for this we need a switch. So switch must be inserted between source and load. So switch may be the MOSFET, switch may be the IGBT, depending upon the requirement. The voltage across the load must be kept constant, so we need capacitor across the load resistance. Similarly, to keep the current constant and opposed to the rate of change of current, we need the inductor in between switch and load in series. Similarly, anti-parallel diode is required across the load when the switch is in off condition to circulate the inductor current and maintain the continuous current through the load. So this is the general circuit diagram you will get in any books. Now here design means what? We have to select the switch, we have to select the diode, rating of the switch, rating of the diode, what is the value of the inductor, and what is the value of capacitor. These four things we have to calculate, and this is not possible without calculation of the current and voltages to the respective devices. Let us see the duty cycle. The duty cycle is defined as the output voltage upon source voltage. So here there are two output voltage. Minimum voltage is 50 volt and maximum voltage is 150 volt. So first calculate the duty cycle for input voltage of 200 volt and output voltage of 50 volt. Hence the duty cycle is output voltage upon source voltage. So 50 by 200 it gives to 0.25, or you can say 25% of duty cycle. The duty cycle for input with 200 volt and output of 150 volt. So maximum output is 150 volt. For that, duty cycle is 150 divided by 200. It comes to 0.75 or 75%. So duty cycle is varied from 0.25 to 0.75. As the duty cycle get increases, pulse width increases, output voltage also increases. Load current. Let us calculate the load current. For a load current, the formula is very simple, which is depending upon Ohm's law. Here the load current with output voltage of 50 volt and resistance is of 20 ohm. So minimum voltage is 50 volt. Hence the current is voltage by resistance, that is I0 is equal to V0 upon R. So 50 divided by 20, it comes to 2.5 ampere. Now let us calculate the load current for maximum output voltage. Maximum output voltage is 150 volt. The resistance is 20 ohm. Hence the current is 150 divided by 20, it comes to 7.5 ampere. From this calculation, it is observed that the maximum load current is 7.5 ampere. Let's select the inductor value first, because we have calculated the current. So inductor values is depending upon the ripple current. How much ripple is allowed through the inductor current? So 20% ripples are allowed. So in the first case, as we have calculated it, current is 2.5 ampere. In second case, it is 7.5 ampere. Let us calculate the inductor for 2.5 ampere output. For a 2.5 ampere output with the 20% ripple, the ripple current is delta IL is zero point 0.2 into I0, that is 0.2 into 2.5, it comes to 0.5 ampere. So let us calculate the inductor value. To calculate the inductor value, the formula is Vs into 1 minus d Fs upon delta IL. So Vs is source voltage, that is 200, d is the duty cycle. Duty cycle for 2.5 ampere voltage is 50 volt, and duty cycle we have calculated is 0.25. So divided by Fs is switching frequency. Switching frequency in the problem is given as 50 kilohertz, that is 15 to 10 raised to 3 into 0.5. It comes to 6 millihenry. Now let us calculate ripple current in the inductor For 7.5 ampere output, for 7.5 ampere output, delta IL is 0.2 times of I0, that is 0.2 into 7.5, it comes to 1.5 ampere. The inductor value is Vs 1 minus d Fs upon Vs into 1 minus d upon Fs into delta IL. Here the duty cycle you have to take the 0.75 because 7.5 ampere is related to duty cycle of 75%, that is 150 volt output. Fs is same 50 kilohertz, that's 15 to 10 raised to 3, and delta IL is 1.5 ampere in this case. So it comes to 0.667 millihenry. So if we observe here, the maximum value of the inductor is 6 millihenry. So maximum value of inductor we have to choose because for minimum current, the current should be current should not reduces to zero. The current should be the continuous in nature, so that the value of the inductor should be on higher side. So inductor value we will choose here 6 millihenry. Next, capacitor selection. Ripple in the output voltage is 5%. So it is given in the problem. For output voltage, let us consider as 50 volt. At that time, the current is 2.5 ampere. So delta V0 is 5% of V0, that is 0.05 into V0. Delta V0 is 2.5 volt. Ripple voltage is 2.5 volt. So capacitor value is calculated using I0 into D upon Fs into delta V0. So 2.5 into 0.25 into 15 to 10 raised to 3 into 2.5. So it comes to 5 microfarad. Similarly, for output voltage of 150 volt and current is of 7.5 ampere, delta V0 is 7.5 volt. If we calculate the capacitor using the same, but here I0 is equal to 7. Here I0 is equal to 7.5 and the V0 is equal to 7.5, it comes to 15 microfarad. So maximum value of the capacitor is 15 microfarad. We have to choose the maximum value of capacitor to get the variation within the limit. So ripple is in the limit of 5%. So we have selected the inductor, we have selected the capacitor. Now let us see how we can select the MOSFET and diode. So maximum voltage across the MOSFET in the off state is equal to the source voltage. So rated value of the MOSFET must be greater than 200 volt, that is the source voltage. Maximum current through the MOSFET in on state is, it must be greater than IL plus delta IL by 2, that is maximum rippled current, it is IL, that is average current, plus delta IL by 2, that is the peak value. So 7.5 plus 1.5 upon 2, that is the maximum current, so it comes to 8.25. So from market you have to purchase the MOSFET rating greater than 200 volt and current rating is 8.25 ampere. Similarly, maximum voltage across the diode is in off state is greater than source voltage, that is 200 volt, and current is also same, that is 8.2 ampere. So diode and MOSFET both should be selected of 200 volt and 8.25 ampere rating minimum. So let us see the buck converter design. So here switch rating is minimum 200 volt 8.25 ampere, diode rating is 200 volt 8.25 ampere, inductor is 6 millihenry and the capacitance is 15 microhenry. Now if we switch on this circuit with the frequency of 50 kilohertz with the required duty cycle, we can get the voltage from 50 volt to 150 volt within the prescribed limit, that is the 20% of ripple current and 5% of the ripple voltage output. So this is the buck converter design. Hope you like this video. So if you like this video, kindly subscribe my channel and share with your friends. Thank you, thank you, thank you.